Good morning, dear students. So today we'll be studying chapter number 4, altitudes and medians of a triangle. Let's recall. In the previous standard, we have learnt that bisectors of an angles of the triangle as well as the perpendicular bisectors of its sides are concurrent. These points of concurrence are respectively called the incenter and the circumcenter of the triangle. I hope you remember this, how we draw the bisectors of the angles and the perpendicular bisectors. Concurrent point means they meet at the same point. Two or more than two segments meeting at the same point are called as concurrent points. Now, activity. Draw a line, take a point outside the line, and draw a perpendicular from the point to the line with the help of a set square. So let's conduct this activity. I will draw a line here, any line. Let's say line AB. Then you have to take a point outside the line. So I'll label here point P. Okay, now using a set square. Now this set square is a right angle set square. So I'll keep it like this on this line here. Okay, and move it accordingly. And as I move it, you can see it will go and meet at a point, coincide with the point P, and then I draw a straight line here. I draw a straight line. So this is the perpendicular. So this is the perpendicular to the line outside the point outside the line. Okay, so this is the perpendicular drawn. So I hope you remember this. Now let us learn how to draw an altitude. Now what is an altitude? An altitude is the perpendicular segment drawn from the vertex of the triangle to the opposite side to it is called as the altitude of the triangle. So in this triangle, you can see A, B, C. Segment AP is called as the altitude to the base BC. Altitude means actually the height. Okay. So let us see how to draw the altitude. So let us draw a triangle ABC. Suppose, let us draw any measurement. A triangle ABC. So here, this is point A, this is point B, and this is point C. Now, again, using the same set square, you can use, okay. So here, we'll keep it like this. I hope you remember this. We have studied in the previous standards. So with this, it will coincide. Point A is outside this line. So we are drawing the perpendicular. What is the definition? The perpendicular segment drawn from a vertex of a triangle on the side opposite to it is called as the altitude of the triangle. So accordingly, we will move this set square and we'll hold it like this. Okay, and then just draw it like this. So this is the altitude. So P, it is a perpendicular drawn. Okay, so I hope all of you will be able to draw it. Now, let us see how to draw the altitudes of a triangle. All the three altitudes we will be studying. So now, let us draw one more triangle. Let us draw one more triangle and then see how to draw the altitudes of it. Any triangle, any measurement you can draw. Let me increase this side. So here. So let's see, this is X, Y, Z. X, Y, and Z triangle. Okay. So we'll use the set square. You can use this set square also. Now this point, the base is this. So we'll just keep it like this, and you can see here accordingly. From here you can draw it. This is the altitude. Now again here also you can see this is the point outside the line. So here we can again draw it. Move it like this. You can use any of the set square and you can draw it like this. And this is also the point outside. So here also we can draw this here. Like this. Okay. So this point O. Okay. The point of intersection. So this, let's label this point as R, this as P, this as Q. These are the perpendiculars drawn on the respective bases. So draw an triangle XYZ. So I have shown you. Draw a perpendicular from vertex X. So from vertex X, you saw how I have drawn it like this by keeping it like this. Okay. Perpendicular X on the side YZ. So this side YZ, we have drawn this perpendicular. Name the point where it meets YZ as R. So we have labeled this as R. Then XR is the altitude. So this is the altitude on segment YZ. Then considering XZ. So this XZ as the base, draw an altitude YQ. So this we have drawn. We have seen this, right? We have seen this like this. We have drawn it. Okay. So YQ is perpendicular to segment XZ. Then considering XY as the base. Now this XY as the base, again we have drawn an altitude here, XP. Okay, XR, sorry, ZP on segment XY. Okay, now segment ZP is perpendicular to XY. So ZP is perpendicular to XY. Now segment XR, YQ and ZP are the altitudes of the triangle XYZ. Note that the three altitudes are concurrent. See that they meet at a single point. The point of concurrence is called as the orthocenter of the triangle and it is denoted by the letter O. So I hope you have followed this. Okay. So here I have already drawn and kept for you this. I have drawn this. I have shown you this, right? Now let us shift to the next page. Now let us see how to locate the orthocenter of the triangles. Now what is the first activity? The first activity is draw a right angle triangle and draw all its altitudes. Now you know that the altitude is a perpendicular segment drawn from the vertex to the opposite side. Now here we have to draw this altitude. So the altitude for this point is here. Okay, yeah. So we have to draw this altitude for this. So for this point B, this is the altitude. Okay, we'll draw this altitude here. Yeah, it's a perpendicular to the opposite side. Now if you see here, this, in case of the right angle triangle, this is already the perpendicular segment. This is always the perpendicular segment. So it's here, it's a right angle here. Yeah, this is a right angle. And here, this is also a perpendicular segment. This is a perpendicular segment. So in case of a right angle triangle, the orthocenter is always the vertex of the triangle. Okay. So the orthocenter of a right angle triangle is the vertex of the right angle here. Because this is perpendicular, and this perpendicularly drawn meets here. This is the orthocenter. I can label it as O also. I can call it as O. Okay. So this is the orthocenter. It is the point of concurrence. So I have drawn it over here and shown it to you. See here. So right angle triangle, if we draw the altitudes, the orthocenter is the vertex of the right angle. So here point B is the orthocenter. Now the second activity is draw an obtuse angle triangle. So here I have already drawn an obtuse angle triangle and kept, and all its altitudes, and do they intersect each other? Draw the lines containing the altitudes and observe that these lines are concurrent. Now let us see how to draw these altitudes. Now let us take a compass or a rounder and then let's draw to this side. Okay, so here I'll draw it like this so that it cuts this opposite side in 2 points. Now these 2 points, let's take greater than half distance and draw one arc here from this point and draw another arc from this point. Okay, so let's join these 2 points to the vertex. Yes, okay. Now next, let's draw from this vertex to the opposite sides here. Now here what has happened is, now here you know that you cannot draw it like that. So you have to extend this. Let us extend this point segment from P. Let us extend this line. Okay. Let us use another color for this, so that you will be able to recognize it. We will extend this segment here. Okay. Now let us see how we can intersect this. Yeah, like this. Okay, from here, not from here, it should be on, sorry, this side. Let's extend this side, and we have to draw it on this side. This segment also we have to intersect. So let us intersect this line also. Let us increase this using another color. Yeah, on this side you have to draw the perpendicular. So here, from here, this side you have to draw the perpendicular. So from here we will take and we will, yeah, over here we will draw. Now see, it is intersecting this line. We have extended this line here in 2 points, this and this point. So we will take greater than half distance. And draw an arc here and one arc from here. Okay, so here we can draw this line here. So it is, yeah, over here. Yeah, over here it is intersecting. Now, so here we can say this is the right angle of this, right? This is the right angle for this perpendicular. And here this is the perpendicular for this segment, right? This is the perpendicular for this segment. Now, let us see how we can draw the perpendicular of this segment. Again, we have to extend this line. Let us extend this line also. Okay. Now, let us keep the rounder and see where you can cut this segment into 2 different points. See, these 2 different points. So here 1 point and here 1 point. Now we'll take greater than half and draw one arc here, and from here one more arc, right? So now we will join these. So this is the perpendicular drawn on this segment. Yes, this is the perpendicular drawn on this segment. Now, let us extend this line also. Now you can see that all 3 of them meet here. And this is the orthocenter. This is the orthocenter. See, all of them meet here. Okay, all of them meet here. So this is the orthocenter. We have to extend these lines. So in case of an obtuse angle triangle, the orthocenter lies in the exterior. So here it is lying in the exterior, the orthocenter. Okay, the orthocenter is lying on the exterior. In case of right angle, it is on the vertex. It is on the vertex of the triangle. Okay, so here you can see the same one I have drawn here. So you can see here. Okay, so this is the obtuse angle triangle. Okay, then we have drawn from here. If you can see again, I'll show you. See here, I've taken this, I've drawn this. Again, greater than half distance, draw one arc here. From the same point, draw another arc and draw this till here. Later on, extend it. Then for this side, we have to draw the perpendicular. So extend this line. So let's extend this line. And from here, we draw 2 arcs here. Let it cut this line in 2 points. So it is cut in this point. So we have drawn this arc here. We have drawn this arc, and from this point again this arc, and then draw the line here, the perpendicular. So the perpendicular is here. Now for this line also we have to, for this point also we have to draw the perpendicular. So we have to extend this line. Let's extend this line. So we have extended, we have drawn with a different color. Again here we'll keep it on point here, and then we'll cut this segment here into two different points and take greater than half, and then again draw 2 points here, here and one here, and then join this. And here this is the perpendicular here, and here this is the perpendicular. Now we'll extend all these three segments, and we'll see that the point O, that is the orthocenter, lies in the exterior of the triangle. I hope you have understood this. You can practice it. Now next, let us draw an acute angle. The activity 3 is draw an acute angle triangle and all its altitudes. So here, let us see this altitudes for this acute angle triangle. Now here, so here we will again draw the, from the vertex, okay, we'll draw this side and we'll see. See, it is extending here. It's cutting in 2 points here and here. So let's take small distance and cut it here, and another one in point here. So we will draw this segment here. Okay. Yeah. Okay. Now next, for this point vertex, it has to cut the opposite segment. So see here in 2 points. Okay. So again we will take greater than half distance of this, draw one arc here, another point here, draw one arc here, and join this. Join these points. Okay. Now from the vertex A, let us see how we can draw. Let's extend it. Yeah. So see, it's cutting this opposite side in 2 points, 1 and 2. So let's take greater than half distance and draw an arc. So here one arc from this point, and from this point one more arc. So let me join this. Let me join this. So here you can see that they all meet at the center here, ortho center, and this ortho center lies in the interior. Here it is lying in the interior of the triangle. Okay, the ortho center of acute angle triangle is in the interior of the triangle. So I hope you have followed how to draw this based on these steps. Okay, so accordingly you will draw all these three diagrams and figures and locate the ortho center. Okay, now let us go to the concept of median. What do you mean by a median? Now, the segment joining the vertex and the midpoint of the opposite side is called as the median of the triangle. So, segment joining the vertex and the midpoint of the opposite side is called as the median. So, you have to learn the definition and draw one figure here. Here also similarly, you have to draw these figures and write about the ortho center. Also here, you have to draw all these, this activity, this altitude, this base, okay, and this. So 1, 2, 3 diagrams here, plus these 3, 6, okay, and here median also you have to draw. Now let us see about it, how to draw the medians of a triangle. Okay, now draw a triangle ABC. Find the midpoint P of side AB. Now to find the midpoint, you have to draw the perpendicular bisectors. You'll know it. Okay. So here, greater than half distance, again from this point. Okay, so they are intersecting here. So let us join them. Okay, so here. Now next, let's see about find the midpoint, then find midpoint Q. So let's label this midpoint as P here. Okay, now for this segment, okay, let's draw the perpendicular bisector of this greater than half distance you have taken. So here one arc and here another arc. I hope you can see here one arc and another one here. Now with the vertex B, let's cut this first arcs over here. See, you can see over here and over here. Got it? So let's join these two segments. Let's join these 2 points here. Okay, so that is the perpendicular for this side. Now the perpendicular for side BC. Again, we'll take greater than half. Okay, now here again, let's cut it, this one and this one. So here we have to join these 2 points of intersection. These 2 points of intersection. Yeah, okay. Now let me extend it, or let it be like that. Yeah. Now what you'd find the midpoint Q. So we have seen that P is the midpoint of this side AC and R is the midpoint here. Okay, okay, midpoint Q of BC. Okay, Q of BC, the midpoint Q of BC. Find R the midpoint. Draw PC again. Now we have to draw PC. Now here we have labeled it the other way. Okay, you can draw from here to here. Okay, PC, BR and the median. So medians will be from here to here. This will be the same segment. It's really nearly the same. Yeah, and from here we'll draw till here. Okay. Yeah, and here we draw this one here. I'll draw dotted line so that little bit darker, so that you can make out. See, you can see these lines. See this line here. These are the medians, and this one here. You have to join it where it meets the midpoint. So this point is called as G. Is called as a G. Note the medians are concurrent and the point of concurrence is called as the centroid. So this G is the centroid. G is the centroid. See, these are the median. This is one median here. This is one median here. And this is another median. So for this perpendicular bisector where it meets on the segment, there you have to join the opposite vertex over there on the opposite side. Again here from B to P on line AC here. And here C to R. Again here it is joining. So here, so we have drawn this. This is the point of concurrence. Okay, this is the point of concurrence. Now we have to draw 3 different triangles: a right angle triangle, an obtuse angle triangle and an acute angle triangle. So we have already drawn this acute angle triangle. This is the same thing here. Okay, the same figure I have drawn here, acute angle triangle and drawn. Now let us see, this is the one acute angle triangle I have drawn. Similar, I have shown here dotted lines. If you can see the dotted lines here. These are the medians. To differentiate, I have drawn it like that. Okay, and let us draw another one, obtuse angle triangle. So for obtuse angle triangle, similarly, we will draw the perpendicular bisectors. Now for this side, let us draw this side here. It should be greater than half. Okay, so we are measuring greater than half. Again, draw one arc here. Draw this side one arc. Again, from this end, again, let's draw this, and if it's not cutting, we have to extend this. So we extend this. So we draw it to this side. Let's join this. Yeah, let's join this. Now, again, let us draw to this side, the perpendicular. Greater than half, I hope you can see. greater than half distance I am taking. So one on this side, other one on the opposite side. Okay, other one on the opposite side. Now the same distance we'll measure from this vertex. We'll draw one here and one here. Now let's join this line here. Right? Now again for this side we will draw greater than half distance. Can you see here? See, greater than half distance. I'm drawing one arc here, greater than half distance. Again here, here. Okay? Here. Now, let us again draw from vertex L. So, this side and this side. So, here, let me draw this. Okay? Yeah. You can see these are the three perpendicular bisectors. Now, for this segment, we have to go up to here. Yeah. So let's draw it here. The median. Then for this one, it's here. Right? Okay. And for this one, so from this vertex we have drawn here, from this vertex we have drawn here, and from this vertex it comes here. Okay, I've drawn broken line. See this broken line here for you to distinguish here this side from this L to this side, opposite side. Then from M, it's this broken line here, and from N up to this perpendicular here. So here we can see that they meet at a point here. They meet at a point here which is called as a G, that is the centroid. That is the centroid. I will show you one more. I have already drawn here. See this one, you can see. This is the median. Again, the same thing I have drawn here. Yeah. G is the centroid which is lying here. Now let us see right angle triangle. Okay, let's draw for the right angle. So I have already drawn a right angle here. So let us see how to draw a centroid for this. Again, let us again keep the rounder. Let's take greater than half distance. Draw one arc. I'll just erase this because it might interfere with this. So let me erase this first one. So here one, and on the lower side. It's going on the lower side. So I'll show you a little bit here. Yeah. So from this side, this here, and one more arc here. Then from the opposite side, one arc here and another one. Now let me extend this here. Let me extend this. See here. Okay. So let me join this. Let me join these 2 points of intersection. Right. Next, for these two sides, from vertex, this greater than half, one arc here. Yeah. I hope you can see one arc from this vertex, another arc from one upside and one down. Okay, so let me draw it again. Let me keep it here properly. Here. One from this vertex and one over here. And then from this vertex. And let it cut. So here. So this is cutting here. And this is cutting here. So over here. Yeah. So let us draw this here. Now for this segment, let's draw the perpendicular greater than half. One arc here, another arc here. We'll extend this as it is not cutting here. So here, extend this and extend this. Now you can see here, you can join this. Yeah, let's join this here segment. Yeah. Now let us draw the perpendicular bisectors of all these three. Now, for this one, it will be here. Yeah. For this one, it will be here. I have drawn the broken line. Then, for this one, for this opposite one, it will be here. Next, for this one, it will be here. Now you can see all three of them are meeting at a single point G. So here this is the centroid. So the centroid always lies in the interior. The centroid always lies in the interior of a triangle. Yes, the centroid. See here. You can see this one I have drawn here. Centroid. See here. Yeah, the same thing. The centroid lies in the interior of a triangle. Now, so we have done this. Now, what is the property of the centroid of a triangle? So, draw sufficiently large triangle ABC. Draw the medians AR. We have drawn all this for any triangle. Sufficiently large triangle ABC. Draw medians, segments AR, BQ and CP of triangle ABC. So, for any of these triangles, we have done that. Name the point of concurrence as G. Now, measure the lengths of the segments from the figure and fill in the boxes. Now, if you measure the lengths, we have seen after drawing, if AG is 3, then GR is 5. Suppose AG, this one, okay. If now let's take this one. If this one is 3, this will measure 1.5. So the ratio of AG to GR is 2:1. It's always double. So now here you have seen this measures 1 centimeter and this measures 0.5 centimeter, half. So 2:1. Here also this measures 2.2, this measures 1.1. Similarly here also this measures 3 and this measures 1.5. So 3 is to 1.5 upon. So it is 2:1. Again BG, if you measure, it is 4.6 and here it measures 2.3. So BG is to GQ is equal to 2:1. Then again length CG is 5 centimeters, GP is 2.5. So ratio of CG to GP is 2:1. So in all the cases, the ratio is 2:1, whether it's this triangle or this triangle. Always the ratio is 2:1. Now I know the medians of a triangle are concurrent. Their point of concurrence is called as the centroid and is denoted by the letter G. For all types of triangles, the location of G is in the interior of the triangles. The centroid divides each median in the ratio 2:1. Now let's discuss. As shown in the adjacent figure, a student drew a triangle ABC using 5 parallel lines. He found that the centroid G of the triangle. How will you decide whether the location of G he found is correct or not? So here if you measure, if you see this is 1 centimeter and this is 0.5 centimeter. So the point centroid is correct. So he has found the centroid correctly. Now let us go to practice set 4.1. So in triangle LMN, so this triangle LMN is given LX. LX is the altitude. Okay, LX is the altitude and LY is the median. So this is the altitude. As you can see the perpendicular. This is the median. Write the names of the appropriate statements. So we have written here. Now draw acute angle PQR and all of its sides, all the altitudes, and name the point of concurrence as O. Now here, if you remember in the first activity, I have shown here this activity number 3. If you see here, see this activity. If you see this activity, this is the same thing. Draw an acute angle triangle PQR, or now here it's labeled ABC, and draw all its altitudes. So, and find the point of concurrence here. Then draw obtuse angle triangle and draw its medians. Now we have seen this here. Okay, these are the medians. This is what I have done just now for you. Okay, so it is shown here. Here we had done this. See, draw obtuse, acute and all, and draw its median. So this is question answer number 3. I've already drawn and shown you. Then draw obtuse angle triangle LMN. Draw its altitudes and orthocenter. So obtuse angle triangle we have seen here in activity 2. Activity 2 we have seen this. So you have to draw this figure, right? Now draw right angle triangle XYZ, draw its medians and show the point of concurrence. So right angle triangle also we have drawn here and we have seen the point of concurrence. See this one, the last one which we did just now. Okay, yeah. Next is I'll show you the 6th one. Before that we'll fill the 5th, fill in the blanks of 7th one. point G is a centroid of triangle ABC. If length RG is 2.5, then length GC will be 5, double now. Yeah, you can see. Then length, if BG is equal to 6, then BQ will be 9, because 6 plus 3, 9, right? This will be 6, this will be 3, total length will be 9. If length AP is 6, then length AG will be 4 and GP will be 2. I hope you have understood this. Now, let us see one more thing, how to draw an isosceles triangle and draw all the medians and altitudes.